Your heroes are scattered. Your floating fortress falls from the sky. Where is my disadvantage?
You lack conviction.
I don't think I...
So that's what it does.
In this clip from the first Avengers movie, we see Agent Coulson shooting Loki with a huge alien fighting gun, which sends him flying into a wall. However, we do not see Agent Coulson receiving any recoil from this scene. Through our math, we're trying to prove that Agent Coulson, in reality, should receive a large amount of recoil and therefore should have velocity in the negative direction.
So these are our known quantities. For the mass of the gun, we saw that it was approximately the same size as an M134 minigun, which has a mass of 19 kilograms. For the mass of Loki, we researched Tom Hiddleston, which is the actor that plays him, and he has a mass of 75 kilograms. For Agent Coulson, we also researched the actor, whose name is Clark Gregg, to get his mass of 79 kilograms. And then for the mass of the bullet, although we can't see it perfectly because it's surrounded by light, we can clearly see that the gun and barrel are really big, so we assumed that the bullet had a mass that was 10 times an average bullet.
The estimation of Loki's distance from the wall is around 10 meters. So the video has a FPS of 25 frames per second. So we calculated that the time it took for Loki to travel from his position where he was standing to the wall, it took 18 frames. So his final velocity can be calculated with 10 meters over 18 frames times 25 frames over 1 second, which is around 13.89 meters per second.
From the final velocity of the bullet and Loki stuck together that we found, along with other given information, we'll now calculate the initial velocity of the bullet. So, according to conservation of momentum, we know that the initial momentum of the system is equal to the final momentum of the system. Because of this, we calculate the addition between all things in the system in the initial stage and the final stage. So we found the initial momentum of Loki plus the initial momentum of the bullet is equal to the final momentum of Loki plus the final momentum of the bullet. Therefore, we can use the given information. So first, Loki's mass, which is 75 kilograms, times his initial velocity, which is 0, plus the mass of the bullet, which is 0.4 kilograms, times our unknown, which is the initial velocity of the bullet, is equal to Loki's mass, 75 kilograms, times the final velocity of both Loki and the bullet, 13.89, plus 0.4 kilograms for the bullet, times the same velocity, 13.89. From basic algebra, we found that the velocity initial of the bullet is 2,618.26 meters per second, which is obviously extremely fast considering a normal bullet would travel at around 500 meters per second.
So we know P initial equals 0 because nothing is moving during the scene, but right after the P final we have on one side of P final, we have Loki and the mass of the bullet moving in one direction, and we have the recoil of the gun and Coulson moving in another direction. So we can set that up to equal Loki's mass, which is 75 kg, plus the mass of the bullet, which is 0.4 kg, times the final velocity of the bullet, which is 13.89 meters per second, equals negative 79 kg, which is the mass of Coulson, plus 19 kg, which is the mass of the gun, times a velocity that we do not know. And once we solve this, we can get that the final velocity that Coulson and the gun should be moving at is negative 10.7 meters per second.